main purpose of our circuit is to have an LED that is off, and if you want to turn it on, we clap. And if you want to turn that LED off, we clap again. To detect the clap, we use a microphone, which the signal provided by our clap will be passed through a low pass filter. If the signal is lower than the cutoff frequency, then it will go to the comparator to see if any noticeable change has occurred. The output of the comparator then goes into the clock input of the decade counter. The output of pin 3 is what determines if the LED will change status. The blue LED is supposed to stay on until the battery is empty. The blue LED will always be on as a way to show that the circuit is getting voltage. The three main components of our circuit are buffer, comparator, and decade counter. The buffer acts as a low pass filter with a cutoff frequency around 60 kHz. To calculate the frequency, we use the formula that frequency equal 1/2 by RC, in which the resistor is 270 ohms and the capacitor is 100 picofarads. And the reason we use buffer is because its gain is 1. Since the gain is equal 1 plus Ri over Rf, in which R is 0 and Rf is infinity. The reason for this is because if we were to add a gain higher than 1, the input to the comparator will be higher than it would normally be. So it would use the wrong number to compare. The comparator will detect any increase in the voltage produced by the microphone and compare it with a constant voltage, and then the output of the comparator will go to the clock input to the decade counter, to the decade counter. The decade counter is meant to count from 0000 to 1010 in binary, or from 0 to 10 in seconds. Basically, when we clap, we start the clock and the output of pin 3 will give power to the LED. Another clap will reset the time in a way turns the clock off, which will reset the time in a way turns the clock off, and that will basically turn the LED off as well. And thank you.